Mr. Mohammed, address to you. Given your perspectives, what drives the shift towards intelligent HVAC systems? And previously, convergence was optional thing among MEP. Now, across electrical, plumbing, and digital domain, it has become essential.
Okay. Super question actually. So towards shift. So today shift towards intelligent HVAC system is primarily driven by growing demand for energy efficiency, sustainability and occupancy comfort, and then operation visibility. That is very, very important. And the most important thing I can say that data driven decision making, because building owners no longer going to look for the standalone HVAC system or standalone HVAC controls, because if you have, as like I said, that if you have the 100 VAV or putting 100 VAVs as a standalone system and maintaining means it is not an easy thing. So I would say is that data driven real time monitoring will be the major thing for the HVAC equipment, because the HVAC equipment, if you are implementing a smart and connected optimized building ecosystems, that reduce the operational cost first one, and also it will improve the performance of the complete HVAC equipment. And then the most important then the user experience, because if the technician is going to approach the 100 VAV, that is difficult for them and that frustrated one. If you are giving them real-time connectivity, that user experience will move. And that, as I said, that smart connectivity, one city having Mumbai city have one building and Delhi have one other building, and you can monitor from the Bangalore. So the smart connectivity will help the building owners also see the performance of the building. At the same time, the convergence across the HVAC, electrical, and then plumbing and complete the digital technology is because it's a very, very essential, because modern buildings operate, uh, it is interconnected with the other environments, rather than just isolating that electrical one side and then plumbing one side and then mechanical one be in the another side. If you're isolating all the things, if you're not interconnecting the system, HVAC system, then what will happen, you could not able to rely on the real time data, because the real time data is the very, very important. If you're collecting from the data, from the power meters or BTU meters, from the occupancy sensor, from the indoor air quality sensors, water systems, and you are analyzing via cloud analytics, that is AI driven, the very famous one, AI driven analytics. If you are making that your integrated building platform like that, you can able to achieve the optimal performance for them. Ultimately, the optimal performance indirectly you are saving the energy and you are reducing the operating cost, and then you are visualizing all the steps in the single table. And also coming to that, this integration is enables, it will give the centralized monitoring, as I said that, and it will help you to do the predictive maintenance. Sitting in a Bangalore, you can give the instruction to the do the predictive maintenance for Delhi side or Kolkata side. So what happens, so because of the predictive maintenance, if you efficiently plan, and you can efficiently planning of that, the this ability, this data driven ability will give that energy optimization, and then you can give that comfort to the tenant. If you are, it's a commercial building, you can give, you are giving the tenant comfort management, uh, giving to them. And then this is the intelligent automation, I can say that, because without convergence, the building will face the fragmented operations, right? Each will be the fragmented, not like a scattered. So if you are making the convergence, high energy consumptions will happen. If you are not, if you are having the fragmented structure, inefficiency in your maintenance, and then limited scalability. So that is the thing actually. The future smart building technology has to provide the full provisions to the building owners and facility managers to operate the complete buildings efficiently. So the future of building will be the intelligent buildings will depends upon the seamless collaborations between the engineering discipline and the digital infrastructure. So where the HVAC becomes the part of the fully connected and the data driven ecosystems. So that is the thing I can say here.
That's very nice and quite insightful. You have covered in a lot regarding the real-time data impact analytical integration and remote connectivity. Well said. Coming to Mr. Dipak Babrekar, what are your views about
Yes,
driving
sir.
shift towards the intelligent HVAC system and its
See, generally,
convergence? Yeah.
yeah, yeah. Generally, what happens earlier conventional system, there was a everybody was working in the silo. Okay. So
Mhm.
if you are going with the digital system, you have to start when you design only, you have to work in integration only.
Mhm.
Integration only. So some specifier as a MEP consultant or you are designer, but now you have to be system integrator. So if you are having some HVE, that is the energy, equipment, and your environment, all these are to impact on your MEP. So if you are planning to have the digital system as a not as optional, so if you are planning to have the digital twin, you will start with the BIM, that is building information modeling, from 3D modeling to the digital twin. There are so many things are happening inside also, but this will have impact on your energy use as well. So if you are not giving energy efficient environment, it will
Coming to Mr. Mohammed again, it's a general question once again. So you were talking about the smart connectivity as well as the remote connectivity. So as building environments become smarter and more connected, what will define high performance HVAC system in the next coming years?
Okay, next coming years. Okay, I can call that. So upcoming years, so truly high performance HVAC system will be defined not only by its ability to maintain the temperature,
Mhm.
but how it is intelligently and meanwhile efficiently, and then I say that autonomously it can respond to the building conditions, and also it will respond to the occupant behaviors, and
Mhm.
then your energy demands in the real time. Because I would say that the next upcoming years, I would say autonomous only the solution that in the real time, if you adjust and adopt all the optimizations, so that will be, it will be a true solution. I can say that the future ready the HVAC system will combined of your advanced sensors and AI driven, like IoT sensors. Now telling, I can say more than IoT sensor with secured, because cyber security also matter, that we are going for the cloud based technology. So AI driven advanced sensor, both the things will connect into the digital twin. It will help you to do that predictive maintenance, and this intelligent building automations will create a adaptive, as I said, that self-optimizing environments. The key that will be the key performance indicator, will extend beyond the basic comfort to include the energy efficiency and also the indoor air quality, and also for carbon reductions, and especially for operational resilience. So that will be important. And occupant wellness, we are continuously talking about that. But about the occupants wellness, we are going for that AI driven analytics, as I said, then initially cyber security. So that has to be careful on this upcoming years. And also integrations will play a major role, because nowadays the integrations, lot of peoples are talking that you want to integrate all the things in the one platform. So high performance integrations required for the high performance HVAC system, because if you are seamlessly communicate with all the electrical, plumbing, lighting, security and renewable energy system, it will give the holistic smart building operations. So we want a holistic smart building operations, we want to integrate all the HVAC system to that. In addition, that I can say that data-driven decision making obviously will become a central to the HVAC performance, because real-time monitoring, fault detection, diagnostics, demand-based controls, occupancy-driven automations, and predictive energy optimization. So it will redefine the how building has to operate that, because nowadays currently we have a cascade-based logic, predefined logic, based on the number of valves are opening, number of VAVs are running. Based on that, we are optimizing chiller set point that. But more than that, we want that all the equipments if you integrate that, so that will give that the building operation performance will improve. And truly I can say that for upcoming years we want a autonomous based data driven and then optimized logic approach to that entire world. And I would say that ultimately the HVAC system is the future, and the HVAC system has to function not now like a standalone system, should not like function like a standalone mechanical system. More than that, it has to go for intelligent digital ecosystem that continuously learn and optimize, enhance both the building performance and then the human experience in the upcoming years.
Well, very well said. Thank you very much, Mr. Mohabbat. Holistic integration and autonomous solutions are going to be the future with the advanced sensors and AI-driven integration, as you said. So, would you like to add to it, Mr. Deepak? Hello, Mr. Deepak. So, while during your presentation you were talking about the how intelligent building works and how the BMS connects with the AI and AI approach for monitoring a smart connectivity, etc. So, in that context, I'm asking what role does plumbing, particularly BMS system, thermal storage, or intelligent building system, or the energy recovery can improve the HVAC efficiency in the smart buildings?
Okay. So the hydronic system. So hydronic
Yeah,
system is
yeah, hydronic system as well,
correct.
including that.
Okay. So the hydronic system, you can say that the plumbing infrastructure planning.
Mhm,
Plumbing infrastructure is plays the fundamental role in improving the HVAC's efficiency. Why I'm saying this, because all the things maximum water or like all mixed water
mhm,
will play in the plumbing, and we are supplying to the heating and cooling coils. So in order to improve the HVAC efficiency using that modern smart buildings, especially through that hydronic system or thermal energy storage or energy recovery strategies, anything. So buildings become a more intelligent and sustainability focused. These systems are becoming a key contributors to energy optimization and operational efficiency. So hydronic HVAC systems, which is chilled water or hot water, or for heating or cooling distribution, significantly giving the
mhm,
more energy efficient than traditional air system or terminal system, because water transfer the energy from more efficiently than air. And this integrated hydronic networks enable the precise temperature control, and you are
mhm.
reducing the fan energy consumption and giving the better flexibility and improve the occupant comfort actually. Because how I am telling that, this plumbing infrastructure, if you are properly done for the all the age use and then your VAV systems, based on this infrastructure, if you are collecting that valve positions, that data is helping to that BMS system to drive the optimal logic, to write down the optimal logic in the supervisor system. And
Right.
also that coming to the thermal storage systems, such as chilled water or ice storage, which is
Mhm,
helping the building shift the energy usage away from the peak demand periods. So what happens? So this allow the HVAC system to operate more efficiently during off-peak hours and reducing the electrical demand charges, and also improving the load management, like demand load
mhm.
management, supporting the grid stability. So we are thinking that what plumbing infrastructure helping this much things means really it is helping that. And also what happened that uh, in the plumbing infrastructure, if you are not properly uh, collecting the data means, like a GPM, gallon per minute, if you are not getting properly mean, it will indirectly you are educating the your system to either go for continuous on, either go for continuous off also. And then I can say that for energy recovery system, further enhance of HVAC performance by capturing the and reusing the waste heat. So you are reusing the cooling energy from the exhaust air or condenser water or any other process system. So in smart buildings, that AI-driven controls and building automation system can continuously optimize this recovery process in a real time, and based on the occupancy, in the real time based on the occupancy, I can say that, or based on the weather condition, I can say that, or based on the peak load of building or building load pattern, how it is beginning, that that we can utilize that. And when we integrate with the intelligence controls on the IoT sensor, whatever I mentioned in the session, so it will give the predictive analytics, and then plumbing related HVAC infrastructure become the uh, major driver of energy efficiency, and also for sustainability operational cost reductions, actually you can say that. And for the you can indirectly reduce the carbon foot minimization in the future ready buildings, actually.
Great. Thank you very much, Mr. Mohammed. Mr. Deepak, is it okay now?
Yeah,
Yeah.
yeah, now,
Hello.
yeah, yeah, yes, yeah,
Yeah, Mr. Deepak, you were talking about some strategies during your presentations. So, what are the quickest wins for energy optimization, smart control, s- system integration, or data analytics, as well as the plumbing design?
yeah. Basically, what happens is I would first rate the system integration is very important, because unless and until you do the integration with the all services like MP, HVAC, suppose if there is some signals is coming from the uh, fire dampers, it is not going to the fire alarm. It will not have that much use, because fire alarm control panel will have all these signals which are related to the HVAC or whatever system they are integrated. So system integration takes place at the first bench, and later the all these things which is coming to happen with the MEP. So what happens is generally earlier conventional system this was not possible. Now with the IT sensor, suppose if I have got temperature
I think we have lost again Shraddha. Hello, Shraddha.
Yes.
Okay. Uh, let him come. So, coming to Mr. Mohammed again to you.
Yeah.
Uh, So, what are the biggest challenges project teams face when integrating electric control systems or BMS for connectivity and smart digital platforms into one coordinated HVAC ecosystem, as you were talking in the presentation?
One of the finest question, actually, day to day we are facing this. Our project team is facing that this integration challenges. I can explain that. So
Correct.
major biggest challenge project team is facing that integrating all the equipments like HVAC equipments, your electrical panels, lighting systems, and then your security and access, fire alarm panels, energy management dashboards, all the different protocols. Like you can say that different languages, actually. Like India have this different language. How one person has to communicate with other language. There is no common languages, like common protocol is not in the BMS industry, actually. Only thing, DDC level, supervisory level, up to front end supervisory system, BMS system level, they standardized it, like backnet, Modbus are standardized. So due to that, so many OEMs are in the market, actually. Honeywell, Johnson Control, Siemens, they are all been in the same communication protocol, so easily integrate the controller level, we can easily integrate. But coming into that integrated digital ecosystem we are talking about, right? Integrating, first most challenges project team will face, that is the communication protocols. So that when sometimes communication establishment will fail, it will not support. Sometimes it will be not a open protocol. The platform is the open, not a open protocol, so we could not able to pull the data from that platform. uh, that's thing, like sometimes they in the site they install the power meters, there is no option for the integration like modbus or backnet, ip or rt based communication features not will be there. So in that time they want to replace the materials, it will be dropped from the integration. So this is one of the major challenge for integrating all the products. The project team will face that. And second one is the framework standardization actually. So when we are talking about ai driven data approach, actually we want a framework. Our, for example, johnson control have the metasys, means that framework have to be open, because they have a different version. All the version not support as a open framework. Like Honeywell
Right.
have that web station, and then Tradium have their software. Siemens have a Desigo CC. So all they are have own BMS software, but the framework are they ready to open to the market? Because if it is not open, we could not able to our in third party our own custom software via API, application programming interface based, we could not able to communicate, we could not able to pull the data. Because we are talking about integrated platform ecosystem. Integrated means here all the things has to come into the single bucket, all the protocol has to be properly converted, and when it has to come into the one bucket, means the framework also has to support. Because one system have one framework and another system have the different framework, means we have to create a custom framework to coordinate each into bring into the one. That one challenge actually. And then another is I can say that multidisciplinary expertise are missing actually. Because one person expert in the building management system, one person expert in the iot architecture, and one
Correct.
person expert in the API and qttj integration, and one is the expert in the electrical and plumbing. Because expertise, all known expertise is in the market is very less. The demand is more for that. Due to that also, we could not able to the project could not able to take more project, or could not able to fulfill their requirement. Because as I said that protocol is different, framework is different, and we have to understand the requirement. And after that we have to bring a common custom platform for them, and we have to convert, we have to put the gateway for wherever needed, and even put the gateway, the data have completely transferred to a centralized platform. So those expertise, multidisciplinary expertise are missing. And due to that the project team is facing a lot of challenges. And then next most thing is everybody talking about AI data driven, and then the cloud based technology you can monitor wherever in the world. That cyber security, and then data management, data what is that, data privacy, that is also very important challenge. Because when you're going for like airport or data center project, the network team will be totally different. We will come up with a open protocol, and they will tell that your protocol has to be answer our cyber security network firewall has to be restricted. So integration again it will be a challenge. We are going for recently we go for on airport project also, network team have their own security. Because data, airport is a very critical area, they have to maintain the data confidentially. They should not be, it should not be open. So according to that we have to develop our own API and securely transfer the data to our integrated platform. And this steady analyze and then implement means that expertise are missing, cyber securities are challenging for us, and then different communication protocol is challenging for our framework, open framework availability challenge for us, because the version is matched. So these are the things are will uh, give a challenges in the current era. Actually maybe in upcoming years we will see that one common platform, one framework that will give open to you with the cyber security of proper firmware or firewall protections. And because integrating on smart platform, giving one smart platform to that user, it's require a high investment, and also for it is required advanced commissioning knowledge, and because it is continuously data driven to that integrated platform. uh, and also you want to do that long maintenance strategies, because we are combining all the communication protocol, all the framework, bring into the one platform, means where, when, which time issues happen, we don't know actually. So in order to stabilize that also, we need a long term maintenance strategies for that. However, that these challenges all will be in upcoming days, upcoming years. It will be successfully integrated with the high efficiency, with the intelligence, because nowadays the technology is emerging, expertise are learning that, and future ready buildings capable to do all the predictive maintenance support, energy efficiency operations, and improved occupants compared to the people, and also for data oriented approach through the holistic smart building system.
That's quite great. You talked about the challenges with the project implementation phases, and as you are telling correctly, so there are different multi-experience talent that is missing. So, like all the integrations, experience also needs to be integrated. So those sort of persons have to be developed. And
Exactly, exactly.
okay, thank you very much for that lively answer. Mr. Deepak,
Yes, sir.
uh, so
Yes, sir.
no issues. We will send you the questions and you can answer it. If there is issue, you can try once again. So I'm asking a very short question to you. Predictive maintenance is discussed as the advantage of intelligent system. So what results do building owners see for the cost saving?
Yes, definitely it will have some, because if you are going with the digital system, it will definitely reduce your capex and opex. How it is? Suppose if you are maintaining the high performance building, so you are using digital twin as a base for the integration. So your capex, so if you are having, suppose your 600 tonnage project is coming, and if you are reducing to the 200 with the high performance and passive challenges, so it will reduce to the 400 tonnage. So you are approximately, if you are having chiller, water cooled chiller, you have 240 kilowatt is your consumption. So that innovation will definitely have impact on your cables, your piping, and definitely ultimately on your system. So our basic things of energy performance integration, that is EPI, what is generally used for the measuring the.
Okay, we have lost once again. Mr. Mohammed, just give me two, three liners. What emerging trends do you see which can have the great impact on the next generation HVAC?
Okay. Yeah.
So
Deepak sir came
your
actually.
energy performance indicator is very important as far as the integration is concerned.
Okay, thank you very much, Mr. Deepak. We will definitely going to send you the questions so that we can cover it in the
Right,
for
sir.
the coverage story. Yeah, no issues. It happens
Okay.
sometimes. So, lastly, coming to Mr. Mohammed, what emerging trends do you see which will have the great impact on the HVAC next generation systems?
Okay, the current emerging trends I'm seeing that currently in the market is cloud data service, and along with AI implementations actually, and
Mhm.
also few lead green buildings. They are expecting that digital twin, which is real-time simulations. These three is the currently emerging in the HVAC industries actually. So that is we are also doing.
Mhm. Thank you. Thank you very much for sharing the knowledge about and the challenges as well, which has come out very well in this discussion. And thank you once again.